points by having a study session for at least an hour with someone else in this class or my second period. Okay, not a BC student because they're working on totally different things than you. But if you have your own study session and you let me know who you were with, what you accomplished, that's fine. You can still get those points. Okay? Were there any other questions I had to talk about? Okay, the other thing. Some of you I've started harassing because you haven't signed up for the AP test. Okay? Many people. And if you have signed up but you haven't paid, that might be a problem. So, after we finish notes, if you need me to print your confirmation page, I will do it for you. I want you to register. You email it to me, I'll print it for you today, and then you can go pay your money in person. Now, if you are paying online, you do not need to print your registration page. Okay? Miss Grissom is answering my texts all the time to confirm people for free and reduced lunch. So if you're not on that list, do it. Because she has to go in, make sure your family's checked off to give you that lower price. Okay?
And you know you have free and reduced lunch?
You still should have checked it and she should have confirmed it.
Yeah.
And if she confirmed it, then you're ready to pay. You still, if you're paying in person, have to print that sheet though. Yes. I will give it to you. Oh yeah, homework 9 was yesterday's. Did anybody else not pick it up? Homework 9. Okay. And then remember that the answer key on 9, 2, and 3 are wrong. And I just sent you a remind about it to make sure that you know. Okay, ready, Marcel?
Yes.
Let's go. Okay, you can do it. Okay, look at number 6. Okay, initially these notes were supposed to be a packet, but I didn't tell Mr. Flesh to staple it, so he didn't. That's why you have many separate pieces of paper. Okay. No, it's my fault. I didn't tell him. He's the man. Okay, what is my A on number 6?
5.
Okay, good, 5. What is my U?
9. 7.
7x, very good. Okay, now, if my U is 7x, what is my du dx?
7.
Okay. Then I'm going to take my dx up. I'm going to move my 7 down so that dx is du over 7. So far, so good? Okay, focus. We're not breaking up with math, so let's do it.
What?
We're talking about breaking up. I was trying to segue smoothly. Okay, so this would be the integral of 3 over 25 plus u squared, and then my dx is now a du over 7. Okay? Then from there, we're going to take the coefficient out to the front of the integral. What's the coefficient? 3/7. Very good. So 3 over 7 is going to come out. Now it's 1 over 25 plus u squared du. Now we're using our rule. Okay, if you do not remember, I will come up on my paper just to briefly show you. Rule number 19 is this. 1 over a inverse tan u over a. So what will my 1 over a be for number 6? 1/5. Inverse tan u over a. What is u over a? 7x over 5. Then plus, let's see. We learned this on Tuesday. Sure. Okay, so I'll come up and show the rule one more time in case you don't have it. Very top of the paper right here. This is also on your pink sheet. Okay, so if you, for whatever reason, lose this at some point, it's still on your pink sheet. Okay? Now, what could I do with the 3/7 times the 1/5? Make it 3/35, yeah? Okay, can I go down? Are we good? Okay, now, if you do not know how to do that, you are going to be toast when we turn it into complete the square. So what I would like for you to do is, on homework 9, I want you to just do one of the ones off the back just to make sure you got it. Okay, so on homework 9, there's a section titled like arc trig or something. I would like for you to do one of them. Yep, this one right here. Does anybody need homework 10? 10. Homework 10. Remember, homework 9 is optional. Do it, don't do it, your choice. Homework 10. Oh, were you gone yesterday for Kindness Day? It's extra credit. Homework 9 is extra credit.
It's extra credit?
Homework 9. Is that homework 9?
Yeah, it's
It is extra
the
credit.
only one that I was actually doing.
Great. You're doing extra credit. Okay, does anybody need homework 10, which is not extra credit, is real normal credit? Okay. All right, turn over to the back, and I want you to try number 8. No, actually, scratch that. Do 9. Okay, so homework 10, number 9. Here you go, Marcel.
Let's go get it together.
Nope, don't do that. I'll get it for you. I love to help. Okay, number 9. If you do not have the rules from Tuesday, I'll put them on my paper. You can copy them down.
You said number 9?
Number 9, correct.
I already did it, so can you check the paper?
Uh-huh. And then integral 1 over minus u squared du inverse sine. Okay. So you should have 2 over, what is it, over 100. Okay, so your problem is that your u shouldn't be 25, it should just be 5x.
What homework is this?
10. You would have gotten it on Monday, actually. Okay, so let's see what you got for number 9. Your a is what? What's the square root of 16?
4.
4. Your u is what?
Why is it
Why is it only 5 instead of 25?
square?
You have to square root it. That's part of the rule. Okay, then your du is going to be 5 dx. I'm just going to go ahead and move that dx up, which means that dx is du over 5. So far, so good? Okay. Now I'm going to rewrite my antiderivative. It's going to be 2 over 4 plus, or I'm sorry, 16 plus, and then it's u squared du over 5. What will the coefficient be that I will be pulling out to the front? 2/5. Very good. Then from here, remember that the inverse tan rule has a 1 over a in the front. So 1 over a would be 1 over 4 inverse tan u over a, which is 5x over 4 plus c. Now, if it was free response, that would be good enough. So I'm just going to circle it and be lazy. Okay, now look at number 10 right next to it. Actually, I don't want, let's do 12 since it's harder. Okay, number 12 is an inverse sine. Okay, so look at number 12. Now, how do we know it's an inverse sine? Because there's a square root, right? And if there's a square root, that means it can't be the tan, it has to be the sine. Okay, what is my a on number 12? Square root of 4 though, so 2. What is my u on number 12? 9 what? X. Okay, that means that my du dx would be 9 dx, because I would move the dx up, which means that dx is du over 9. So far, so good? Okay, then I'm going to rewrite my integral, bless you. It's 5 over 4 minus u squared du over 9. And then what's coming out to the front?
5 and 9.
Okay, 5 over 9. Integral 1 over. You probably don't have to write this step, but you can if you want to. Okay, and then I recognize that this is my formula. Now, does this one have a 1 over a in the front if it's sine? No. So it would be 5 over 9 inverse sine u over a, which is 9x over 2 plus c. Good? Okay. We are going to, before we get into complete the square, we're going to do these two formulas with endpoints just to make sure you got it before we get into a new technique. So if you will take the paper that you picked up today that looks like this, and I want you to flip it over to the back. Okay? And you'll notice that there are 3 practices, okay? And we're going to do this one. Now, first let me ask you, which formula is this? Is it an arcsine or an arctan?
Arcsine.
Arcsine. Do I need to do u substitution if it's only an x squared?
No, man.
No. What is my a?
2.
2. What is my u?
X.
X, which means that my du dx is just a 1 dx, and that's why I don't really need u sub. Okay, no need for u sub. I'm ready to do my formula. What is the antiderivative of that thing? Okay, remember it's inverse sine u over a. So what will it be here? Inverse sine, and then my u is an x, my a is a 2. Now, if I have endpoints, do I need the plus c? No. So I'm not going to put them. I'm going to plug in root 3, and I'm going to plug in 0. Now, some of you guys on your test are not putting plus c, but you're also not putting brackets. That's wrong. If you're not going to put brackets, you have to put the plus c, or else you'll lose points. But if you show the brackets, then you're allowed to drop the c. Okay? So we're plugging in root 3. That would be the inverse sine of root 3 over 2. We did not change the points. That's a great question. If you go back to your x's, you're using the original endpoints. So since I went back to x in this case, I'm using the same endpoints.
Why are we using 1 square root of 3?
Because that's what my upper bound was a root 3, and then I'm plugging it into x over 2.
I'm sorry, I'm looking at the wrong part.
Oh, okay. And then on the bottom, I'm plugging in 0, yeah? Okay, now, in case you were not in here in the fall, or maybe, I don't know, you were asleep. Okay, remember that arc trig is just trig backwards. So instead of them giving you the angle and you giving them the value, they're giving you the value, you're telling them the angle. So if I want sine of root 3 over 2, I need 3 sine fingers. Sine fingers are top or bottom? Bottom. Remember, sin goes, okay? So 1, 2, 3 sine fingers. I'm folding this one. What angle is that? Pi thirds. Okay, next I want the inverse sine of 0. That means I want 0 sine fingers. Well, then I want this one. What finger is that? 0. Okay? Then from there, I do pi thirds minus 0, which is a. Okay? Okay, come down to number 3. Is this one going to require u substitution?
Yeah.
Yes. So, number 3, label your a and your u for me, please. What is my a going to be on number 3? A will be a 1, because it's the square root of 1, and u will be a 2x. Okay, what's du dx? 2. Then I'm going to move my dx up. I'm going to move my 2 down, so that dx is du over 2. So far, so good? Okay. From here, we are going to rewrite our integral as 1 over 1 plus u squared, and then du over 2. Now, somebody in the other class was confused about, why is the dx on the top? That doesn't matter. If you like this better, look, watch. Move it over. Make it a 1. That's the same. So they sometimes will plop the dx right on top of the fraction, but that doesn't matter. Okay, from here, bless you, what is my antiderivative of this using your rule? 1 over a inverse tan u over a. What will it be? 1 over 1 inverse tan u over a, 2x over 1. Now, what was already in the front that I forgot to write? Yep, you got to take this little friend, put it in the front. So really, I have a 1/2 times my 1 over a. Okay? Now, yes?
Why did you keep it as 1/1?
Because this is like my 1 over a. And so since my a was a 1, you don't have to put it if you don't want to. I'm just putting it to show the formula. Okay? And then this is inverse tan u over a. We good on that? Okay, now, one other thing. So the 1/2 and the 1 can go together. If you leave your inverse tan in terms of x, you do not change your endpoints. Remember, you're only changing them if you want to leave this as a u. Okay, for trig, I don't do that. I just go back because I think the shortcut's confusing when you leave it as a u, but you can do that if you want to. Okay? So because I went back to x, I can use my original endpoints. So on the top, I'm going to find f of a half. On the bottom, I'm going to find f of 0. But one more time, I'm using my original endpoints because I went back to my original letter, which was an x. Okay, so I have 1/2 inverse tan of 2x times now a half in there. What is that? 1. Okay, now if you don't remember how to do arc trig, remember they're giving you the number, you're giving them the angle. If tangent is sine over cosine, and it has to divide to be a 1, then sine and cosine have to match each other. That's the only way they can divide to 1. So which finger is going to make sine and cosine come out equal so that they divide to 1? Okay, which one is this? Pi fourths. Is pi fourths my upper value then? What is it? 1/2 times pi fourths. So what will it be? Pi eighths. Very good. Okay? On the bottom, I'm plugging in 0. It would be a half inverse tan, bless you, of 0. Because really it's a 2 times 0, but we know that's just 0. Okay, now remember, tan is sine over cosine. So if I want sine to be 0, that will make tangent 0. Which finger gives you no sine fingers below it? Okay, pinky, which is 0. Then what do I do with those two endpoints? Subtract. Pi eighths minus 0 is pi eighths. Okay, now look back at your homework 10. I'm not going to have you do it now, but do you see these 3 at the bottom with endpoints? Okay, you can use the one we just did, or the 2 we just did to help you with those, okay? Yes? Sure. Okay, the last thing that we're going to learn today, okay, is how to use complete the square to do these. So in order for you to use complete the square, you have to know how to do complete the square. So turn this paper over, and I'm going to reteach you that really quick. Yes? What about what?
Like sine is also 6/2 at 5/3.
Just, so on the AP test, they would say on the integral from 0 to pi, and they would give you a specific thing so you'd know which one to pick. So that's a good point, and you're right, but on the AP test, they're better about, they'll isolate it to where you have to use a certain value versus choosing any value. Okay? Alright, so at the top, complete the square. Do you remember the shortcut for expanding a plus b squared? Okay, what is it? It's something plus something plus something. You know it. I know you know it. Square, double square. I heard a cute little thing in second period. No? So it's a squared, double ab, and then b squared. You remember that? What? Okay, that's okay. So here is how complete the square works. You are going to take the middle number and you're going to cut it in half. So if it's a 6, I'm going to cut it in half and get what? So this is going to be x plus 3 squared. Okay, however, some crap ends up getting left out. You need to know how much will get left out. This is what you do. You're going to expand this out using your square, double square. And you're going to see how much of the 20 gets left out of the perfect square. So, blank, blank, blank. I'm going to do square, double square. So it's going to be x squared. Double 3x is 6x. Square 3 is 9. How much of the 20 is left over if I only have a 9 in that perfect square? A plus 11. Okay? All right, let's do the next one. So ready? I'm only taking half of the 10. What's half of 10?
5.
X plus 5 squared. Then square, double, square. Okay? So it's going to be x squared. Double it is how many? 10x. Because I'm doubling 5, right? And then I'm going to square 5. What is 5 squared? 25. How much is left over from the 30 that didn't get included in this 25? A 5 left over. Okay, one more. What's half of minus 8 in the middle? X minus 4. And then I would expand that out to see what gets left over. Square, double, square. So it'd be x squared. What is my double in the middle? Double 4 though. 8x. And then my last term is the 16. Now, out of the 16, it was originally a 20. How much is getting left outside of the parentheses? A plus 4. Very good. Does that make sense? Just that one step is good? No? Yes?
I'm confused on whenever you're doing the last part.
Okay, let me make it easier. Don't even think about this. Just square what the number is and see how much is left over. What's 5 squared?
25.
How much is left over from 30? 5. What is 4 squared? How much is left over from 20? 4. What is 3 squared? How much is left over from 20? 11. That's really the only piece you have to be able to do. Okay? So come down to number 7. We're going to complete this square on the bottom. Okay? So it's going to be the integral of 1 over, what is half of 4?
2.
X plus 2 squared. Now, what is 2 squared?
4.
How much is left over from the 16 if this only counts as a plus? I said that wrong. How much is left over from the 20 if I only have 4 in here? A 16. So far, so good. That's step 1. I did complete the square. Questions? Okay, step 2. You are going to reverse the order so that this matches your arctan formula. So you're going to write it like this. 1 over 16 plus x plus 2 squared. Now it's an arctan problem. What is my a going to be? 4. What is my u going to be? X plus 2. Yes, Yoel?
Why didn't it work the other way?
It does still work the other way. I'm just trying to make it look exactly like the rule so that nobody will be confused.
So you think it's,
You could leave it like that and just know this is the a, this is the u.
why can't you use x plus 2 as a
Because it's not a number. A has to be a constant. Okay? So, u is x plus 2. Remember just the middle, because we have to square root it. Okay, then what is du dx if it's the derivative of that? 1. Very good. Then move your dx up. Then move your 1 down. Dx is du over 1. Now we're going to rewrite our integral. So I'm going to have the integral of 1 over 16 plus u squared, and then this is now going to be a du over 1. Now, if I wasn't doing this as your notes, would I put the over 1? No. Okay, we're going to go ahead and put it for now. This is 16 plus u squared, and then my dx is now a du over 1. Okay, but we're going to pretend like it's a different number so that we know we have to move it out. So the 1 moves out, whoop, to the front. And what is the antiderivative of that using your rule? 1 over a inverse tan u over a. So what's my 1 over a? A 4th inverse tan u over a. What's my u over a? Plus c. Now, why do I have a plus C on this one? Because I don't have endpoints, right? If I had endpoints, I wouldn't need the plus C. Got it? Okay, let's do another one. Look at number 8. Okay, do the first step. You're going to do the complete the square step. So I'm only taking half of 10. How much is half of 10? Okay, so I can only do x minus 5 squared. Now, what is 5 squared? 25. How many will be left over then if it was originally a 29? Plus 4. Then after I do that, to fit my rule most closely, I'm going to reverse the order of the addition on the bottom. So it's 4 over, 4 plus x minus 5 squared dx. Huh? You cannot cross out those 4's, so don't do that. Is that what you meant? Yeah, you can only cross things out if they're multiplied together. So if this was 4 times x minus 5 squared, you could have crossed them out. Okay, from here, what will my a be? 2. What will my u be? X minus 5. What will my du dx be? 1. Then what do I do with my dx? Move it up and move my 1 down. Then I'm going to rewrite my integral and I'm going to use my rule. So it'll be the integral of, now do I want to leave this 4 here on top? I'm going to pull it out here to the front. So it'll be 4 times the integral 1 over 4 plus u squared. And my du is over 1. Okay, this is the last time I'm going to make you put the over 1, because really we know that doesn't make a difference. Okay, then this in here is your rule. It's your rule number 19. Okay, what's the integral of 1 over 4 plus u squared? It's 1 over a inverse tan u over a. So it'll be 1 over what? 1 over 2, because remember we want to use our a. And then inverse tan. And then u over a would be x minus 5 over 2 plus c. Okay, I'm wrong because I forgot something. Yep, the 4. So remember, that 4 needs to stay there in the front so that now it's not just a half, it's half of 4, which is what? 2. So 2 inverse tan x minus 5 over 2 plus c. And then you're done. Perfect. Great. Awesome. Questions? Okay, before we add endpoints, I want you to try one off your homework. So I'm going to have you do number 13. So on homework 10, number 13, give it a shot. Okay, give it a shot. You're just doing your complete the square method. You should end up with a tan in your answer. And you can square root 81. So that's why that's a fine A. Okay, so if you're confused on that first step, you'd take half of 6 is x minus 3. 3 squared is 9. Out of 90, how much does that leave behind? 81. And then in my next step, I would reverse the order there so that really this is 1 over 81 plus x minus 3 squared. Okay? Then from there, what's my A? Square root of 81. So 9. My u is x minus 3. And then if I take the derivative of that, I'm just going to get a 1. So I'm going to skip to dx is du over 1. Now, that will always happen because if you remember complete the square, you are only allowed to do complete the square if the a is at 1. So if this is not a 1 right here in the front, you're not even allowed to do complete the square anyway. Okay. So then from there, my integral will be 1 over 81 plus u squared du. And then I'm using my rule from there. Remember, it's 1 over a. So 1 over a would be what? 1 over 9 inverse tan. And then u over a would be x minus 3 over 9 plus c. Got it? Okay. Are we ready to put endpoints on it? Okay, so go back to your notes. And you'll notice that on the back side, the 2 with endpoints, there's one above it that we'd skipped. That's the complete the square one. Okay? So this one right here. Okay? Go ahead and set it up for me. Okay, and then we're going to change this upper endpoint to a 4. So if you want to go ahead and change it now, that'd be good. Okay, what is my complete the square step going to be? Half of 12 is how many? Okay, so x, actually I'm going to just reverse the order here. X plus 6 squared, and then how much is going to be left over if it's a 6 squared? Okay, 4. I'm going to write it like this. Is that okay? See how I just kind of switched it in that one step? Okay. Integral. And then my a is going to be what? 2. Yes?
You don't write the points.
I'm just leaving them off until I'm ready to use them. So a is a 2. U is an x plus 6. Du dx is a 1. And then I move my dx up and I move my 1 down. Okay, which, as I said just a minute ago, that's always going to happen when it's complete the square. Okay, we're going to rewrite our integral. 1 over 4 plus u squared du. Let's take the antiderivative. Open up my box here. What's the antiderivative of 1 over 4 plus u squared? 1 over 2, 1 over a, inverse tan, and then u over a, which is what? X plus 6 over 2. Now, question, is my antiderivative in u's or x's? X's. Then do I change my endpoints? No, you use the originals. So we change the upper endpoint to a minus 4. We changed the lower, or we left the lower endpoint the same. Okay, let's plug these in. So first I want a half inverse tan of negative 4 plus 6 over 2. What is negative 4 plus 6? And 2 divided by 2 is 1. Do we remember what the inverse tan of 1 is? We just did it a little bit ago. Not 0. Which finger makes sine and cosine the same so they divide to 1? Pi fourths. Now, is it only pi fourths? It's a half of pi fourths, right? So what would that be? Pi eighths. Okay? Then on the bottom, I'm plugging in negative 6, but what's negative 6 plus 6 on the top? 0. And then what is the inverse tan of 0? 0. Then what do I do with pi eighths and 0? You would subtract them, get pi eighths as your answer.
Why don't you plug in the u value?
Okay, so this is why. If you're going to do, normally I would say do the shortcut all the way, but with tangents, I feel like it gets confusing with the a and the u, so I would say for exclusively inverse tans, I would just go back to the original x so that you don't have to change your endpoints. So when I switched it back to be an x over 2 instead of a u over a, that's when I was able to use my original endpoints and not have to change them.
So was it -2? Was it just a typo? It's supposed to be a negative.
It should have been a -4, correct. That is not a change of endpoints, that's me making a typo, correct. Questions? Yes? So if you're going to do that, you would have to leave this as u over 2, and then you'd be still getting the same answer. But since I went back to make this an x plus 6, that's why I used the originals. If you left this as u over 2, then you could change your endpoints, but you'd get the same answer. Okay? Questions? Okay, 2 things that I want us to do right now. We don't really have time for that last page, but I'm going to record them, and I'm going to send them to you. Here's why. If you pass the AP test, I know this is kind of down the road, but the AP test doesn't cover these identities. So if you go into Calc 2, you'll almost for sure have these in there, and I don't want you to have never seen it, but I think if I try to cover it fast right now, it's going to make people confused. So I'm going to send it out. If you are going to do any sort of engineering, you're planning on taking the AP test, you think you'll probably pass it, you should watch these, but it'll take like 8 minutes. Okay, so I'll do both of them, I'll send it out. Okay, you should watch them, but they're not on the AP test. But they will be covered in Calc 2. And so if you're going to probably pass and skip to Calc 2, I want to make sure that you've kind of seen this kind of crap before, okay? Right now, if you have not registered for the AP test and you are planning on taking it and you are planning on paying in person, email me your confirmation page. I will print it for you right now and give it to you so that you can register and pay. When do you have to pay by to not pay a late fee? Okay, if it's in person, it's tomorrow. Now, if it's online, you have till the 18th at like midnight. Okay, but if you're going to pay by cash or by check, the deadline is tomorrow at the end of the day. Now, can you still register through that late deadline? Yes, but if you're free and reduced lunch and she doesn't know you registered and she forgets to check it, you won't get your cheap price. So take out your laptop right now. Register now. If you need to email me your confirmation page, I'll put my email up here for you. Not on this though. Okay, it's going to be Bethany.Joyner. I love to print things for you. I'll do it. Okay? At risd.org.
I love getting that lovely reminder. Wait, did I find number
Yes, I'm going to keep reminding you so many times. What?
Wait, can we do number 16? Like, do we know how to do it?
Yes, you can do now that whole homework. And you do not have a quiz tomorrow. Your home. Okay, yeah. Just hang on 1 second. Let me pass these out, or try to pass these out. You want to help me, Marcel? Do you know people on this
I know. I know some people.
Some people.
Okay, Alexa.
You gotta come up to me. You gotta
that
come up to me and ask me.
I'm so sorry. My bag?
Some of them kind of go together. Yes. Jose. Marcel, yours is on your desk.
What are you talking about? Tony Browder and Neil.
Sure.
When was this next participation class?
Are you paying online or with my cash or credit? Oh, no. So if you do it online,
Where's he going? What do you get for number 2?
but if you're first reduced lunch, or okay, then you need to do it today because Miss Grissom has to like check you off. So why don't you just do it now? Go to total registration, get on it, because she has an extra thing she has to approve. And if she doesn't see it, like over the weekend, yeah, she'll either get
How did I get a different answer?
Yes.
We worked on the same thing. We were doing the same thing.
No, we were. Only have your.
Wait, hold on. Marcel,
So it'd just be the integral
I got
of that.
a 14, bro. She
And
got
so
a 17.
you have to do.
Marcel, let's put your I'm not Eritrean, bro.
This one, your remainder is just a 4. Right. So it'll be 3x squared plus 4 over 2x plus 1.
Yeah.
What'd you get for A? Yeah.
1/3 u.
That's okay. On the bottom,
So we
should
can put
be
it back
x
in.
squared. That's what should be on the bottom.
Oh, so the top
The top is the remainder,
And you try to do the
and then the bottom is, yeah. Oh, no, that's right.
So then,
Hold on, something is
I thought I got
your D, okay.
I like how you
right
came in
here.
with
What-
we're
this
gonna
is
get
the
100
formula.
on you. We're gonna get 100.
I know.
So your DU is
This is
now
such a
2x minus 4.
You had so much
Good? Okay, yes. Then do log in. Have you ever taken a new PTS? Okay, so then if you still know your login, you should just
Yeah,
use
I
that.
think that
And I
was-
think you can do like a forgot your password option. Yes?
Yeah, I deserve it.
Marcel, you can correct it.
I just don't understand how we got 2 different grades and yet we worked on the same quiz together.
I know. Wait, did you just correct the quiz?
Yes, I did.
Wait, for real?
We can correct any quiz test.
You forgot your one, okay, yeah.
Oh,
So then what's
dude,
it?
You've been in this class for how long? Do you know that?
And U over 2.
No.
Okay, yeah, you're on the right path.
But then, like, do I plug in these to the equation and then change those?
When you go back to x over 2, because you're doing.
I don't know how we worked on the same
U
quiz,
over 2.
and yet we got 2 different.
Or anything that different quiz.
It's really not even, so the only reason I switch back on these is
I got
because
3
when
points
there's
higher.
A and U and changing
But
endpoints.
one question you got wrong and I got right.
So when you get to here, it's U over A,
Some
you're
questions
making
we
it
got
x
this
over
year.
A and you're using it.
So.
Correct. Now
No,
this
I would've-
you were overconfident in this. You were like, we're gonna get a.
So that should be
I
a bracket.
thought I was.
And we were working here.
Plus
Because
and then
F2 and F0.
But I was confident, like, it was, it was like,
you may have to download it because you have to be logged in on my computer.
the whole use up thing.
So just
I
save
don't know.
it, email
I
it to me,
messed
and
up
I'll
the
print it
trick.
right now.
I messed up the trick part.
This one right here. So,
Yes.
Gucci, right?
Gucci about what?
Like, what else you doing?